4. We started by just looking at just some new vocabulary. The neat thing about polynomials is technically you haven't really done it up until this year. So unlike fractions and decimals and all that kind of stuff, it's like I expect you to have some prior knowledge coming into the course. Polynomials, we're kind of starting fresh. We start with new words, we start with just like very the basics, and then we build up to the bigger stuff at the end. So polynomial vocabulary. A polynomial is made up of different terms, and we can identify terms by the things that are separated by plus or minus signs. So here, these are our different terms. And so those plus and minuses really are breaking it down. We have some fancy words to be able to classify things based on the number of terms. What do we call it if there's only one term? Monomial. Which I find hard to say sometimes, so. All right. What do we call it if there's two terms? Binomial. That one's easier. What do we call it if there's three terms? Yay. And what if we have more than three terms? We just call it a polynomial. We run out of fancy names, because technically we could go forever, but that's a waste of our time. Okay, so next what we learned was some more vocabulary about the coefficient, the degree, and what are constants. So the coefficient is a number that comes before a variable. It will always include the plus or minus sign that comes in front of it. If there is no coefficient, then we assume that there's an invisible coefficient of 1. So looking at this example polynomial down here, for our coefficients, we have an invisible 1 hanging out at the front here, and we're even assuming that this invisible 1 is positive. You don't ever have to write those things, but you can if you want to. Then we have a coefficient of negative 20. We have a coefficient of plus 7. And this 13 here doesn't actually count as a coefficient because there is no variable attached to it. Next up, what we have the degree, which is the exponent on the variable. And once again, we know this from last unit. If there is no exponent, then the invisible exponent is 1. So here are degrees. We have degree 4 for our first term. We have degree 3 for the next term. For whatever reason, I didn't put degree 2. What would be the degree of this term? 1. Which again, we usually don't write. And then what would be the degree of this last term? Yeah, this would be degree 0 at the very end. And then lastly, what we get to is the constant. And so a constant is any term without a variable. And so in this case, our constant is plus 13. Again, for any of our numbers, either the constant or the coefficient, we always include the sign that comes before it. So in this case, it's a positive 13. If this were a minus sign right here, our constant would be negative 13. Any questions? Okay, starting out strong with vocab. Next up, the reason why we needed to learn about degree is because of standard form. So just like in fractions, where every time we answer a question that's a fraction, we want to simplify it to its lowest terms. Anytime we answer a question with polynomials, we want to make sure that it's in standard form. So that'll either be highest degree to lowest degree, or if we have all similar degree terms, then they will have alphabetical order. So looking at this one, all you do is you pick up that entire term, including the sign that's in front of it, and just move it around. So our highest degree term would be negative x cubed. So we're going to take that first. And so again, we're looking at the exponents right now if those are different. Then our next highest degree term would be the 5x squared. Again, we want to attach it with a plus sign because we're assuming that that's a positive 5x squared. And then we're done with that one. Then plus 3x, and our constant will be at the very end. And so again, with a lot of things, we want to make sure that we haven't missed anything or squished stuff together that shouldn't be squished together. So here we had 4 terms. Our standard form should still have 4 terms. They've just been like moved around to be in order. So we can double check that it's in the right order because we have 3, then 2, then an invisible 1, and our constant 0. So as long as that's going down in order, then we're good. These ones, they all have degree 1 because they all have just an invisible 1 on each term or on each variable. And so for these ones, we're going to arrange them alphabetically. So our a term will go first, so minus 10a. Then our b term, so plus 8b. And then our c term, so minus 6c. So notice for these ones, when we were just rearranging for standard form, there were no like terms that we could combine together. So this one, we just focused on moving them around. We also didn't go through and tried to jam them together into just one thing, because again, they are not like terms. And so that is what we're doing next, though, is simplifying polynomials. So you can combine like terms if they have the exact same variables and exponents. And for this, we really need to remember that we are adding or subtracting the coefficients, and then we are keeping the variables the same. So I like to say the reason why we can join them together is because they're matching. When they do join together, we need to make sure they still match whatever they were similar to at the start. So for this, we can look at it and say, okay, looking at this one, we know that our answer should be in standard form, so we may as well look for what order that should be to start, so we don't have to rearrange it again after. So if we have m's and n's, what one should go first? M. Yeah, you have to think of the L, M, N, O, P. So m's will go first, so we want to look for anything that has an m in it. And so what we have here is a positive 10 and a negative 3 for our m's. And so we're really looking at just jumping up and down the number line. So we're starting at 10 and we're subtracting 3. That'll bring us to 7m. And now we're done with those. So now we can take our n terms, and we've got 2n minus 8n. So 2 minus 8 gives us negative 6. And again, it needs to match. We're not joining those variables together. They don't become n squared, even though we're kind of taking two of them and putting them together. It's still just n regular. For this one here, we've got different degrees. So we'll look for our x squared terms first. We can say, okay, we've got 4x squared minus x squared. Again, we need to remember that there's a 1 there. So 4 minus 1 is 3. And the reason why they match is because they had x squared. So they match with an x squared here as well. Then we can find our x's, negative 2x and plus 5x will give us plus 3x. Yeah. And then we can look at our constants, and we have positive 3 and positive 9 will give us 12. Just regular basic math. If you were to, for example, have, let's say this, how would this change things? If I had a 2 there instead of what was originally a 5, then what we would have is negative 2x, and then imagine that it was a plus 2x. Those would cancel each other out fully, and we would just have no x terms at all. So if, when we're combining like terms, if they're opposites of each other, essentially we'd be thinking negative 2 plus 2 is just 0. And so that just zeroes it out. That term is gone forever. I didn't give you an example like that. I do believe there's an example like that in the practice test, though, so you might see that today. Okay, any questions so far? Our next bit is all about algebra tiles, which you either love or hate, and I respect your decision either way. So for this one, we're looking at these. I'll keep this on the board for Monday as well. I don't want you to lose marks just because you can't remember that the big square is the x squared. Although by now I'm sure we've got it. When we look at a pile of algebra tiles, we can cancel out things that are the same size but different colors. So here we could cancel out these two big squares. We can't cancel out any rectangles because they're all filled in, but we could certainly cancel out some little squares. Those cancel out, those cancel out, those cancel out. And what we're left with is one large, not filled in square, which will be negative x squared. We also have 3 rectangles that are filled in. So because they're filled in, that'll be plus. Because there's 3 of them, that'll be our coefficient. And rectangles are x. And then we have just one little constant at the end, so we'll have a plus 1. Cool. Flipping the page. We are adding and subtracting polynomials. And so adding terms together is the default operation in polynomial stuff. So technically all we're doing is just looking at this as if there were no brackets here and combining the like terms. Subtracting will be a bit different. But if you want to, you can just kind of rewrite everything that's there. I do recommend this. I also like to then attach the signs to the terms to look a little bit closer to what they're attached to. I don't know, it helps my brain out, but you do you. And then we just find what's matching. So our 3x squared plus 3x squared, that will give us 6x squared. 9x plus x, so 1x, will give us 10x. So plus 10x. And then we have -1 minus 5 will bring us to -6. So again, these are adding and subtracting, so we don't have two negatives making a positive.
It's plus 5.
Oh, it's a plus 5. I'm so sorry. Okay, so in this case, let's fix that. Thank you so much. So we're starting at -1 on the number line. We're hopping 5 steps that way. Will bring us to +4. Thank you. So that is the danger. If you are rewriting stuff from before, make sure you write it properly or else that happens. With subtracting, we do have to think a little bit more. There's an extra step you definitely have to take. This one especially, I recommend writing it out. The people who don't write it out, I guess you could challenge yourself, but then if you get it wrong, you get no points whatsoever. So what we're looking at here is we're taking this negative and distributing it to everything after the brackets. This negative is actually not attached to these brackets at all. So there's no effect there, and we can just write that one out like usual. 3x squared plus 9x minus 1. Now every term in this polynomial will switch its sign. So since this first term was originally positive within the brackets, it'll become negative when we distribute the negative sign. This one is also positive in the brackets, so it'll become negative. But this one is starting as negative, so essentially what we're thinking is minus -5, and we know two negatives when they're next to each other like that will become a positive, and so that's why it becomes +5 over here. So now that we've gotten rid of those brackets, we can combine the like terms like usual. So we look for our things that match in the order that will make our answer easier. And so in this case, there we go. We have 3x squared minus 3x squared. Those completely cancel each other out. Then we can bring together our x's. We have 9x minus x, so that will be 8x. And then we have -1 plus 5, so that'll give us +4. Can we join these two things together to give us 12x? No, they are not like terms. This one has an x, this one does not, so they cannot join together. This is just our final answer. Okay, any questions on that stuff there? So up until this point, when we join stuff together, the variables are not changing. Now, as we go to multiplying and dividing, we notice that we see some stuff from Unit 3 about changing the variables. So with multiplying, we multiply the coefficients, and then we multiply the variables, which means that we have to add the exponents. So we look at this, let me zoom in, there we go. And we can say here, what is 4 times 3?
12.
And that gives us 12. And then the x5 has no other x's to join with, so it just stays x to the power of 5. When we look at the next one, same thing, we can find our coefficients. 2 times 7, what does that give us? 14. And this time, we definitely have some stuff we can do with the x's. So we have x to the power of 4 times x to the power of 5, which means that we are adding those together, which will give us x to the power of 9. If we're multiplying more than just monomials together, then we're looking at distributing the monomial to a couple of different things. Again, we want to make sure that we follow the rule. If we have 3 things in the brackets, our answer had better have 3 things outside of the brackets. They're just going to become 3x times bigger. So we're taking this 3x and we're distributing it. Again, if you want to cross things out as you go to make sure you don't miss anything or just to keep yourself organized, absolutely go for it. But we're first focusing on just this part, forgetting any of that stuff there. So 3x times 4x squared will give us 12x cubed. And then we're done with that. And then we're just doing 3x times x, forgetting anything else there exists. So that'll be 3x squared. It's a positive 3, so we attach it with a plus sign. And then we can do 3x times -2, forgetting any of that stuff. And so that'll be negative 6x. And again, we can double check some patterns here. So we originally had degrees of 2, 1, and then 0. But we added an x to each one, so it should up it by 1. So now we've got 3, 2, and then 1. So that makes sense. Any questions there? We are almost done. I'm trying to whip through this because it is a Friday and I want you to work on some stuff. So next we've got dividing. And so similar idea, we're dividing the coefficients and then we're subtracting the exponents like we did in unit 3. So what's 10 divided by 2? It's 5. And then in this one, we only have x to the power of 4 on the top. There's nothing else that it will cancel with or subtract. So we just have that x to the power of 4 as part of our answer. For this one here, we definitely have some more stuff we can do. So what's 36 divided by 9? Excellent. And then if we have 5 x's on the top and 2 x's on the bottom, we're subtracting those exponents. So 5 minus 2 will give us 3 x's left over. There we go. Last unit, we did see a lot of stuff where we potentially had the x's remain on the bottom. In this unit, our x's are basically always living on the top when they cancel out. But as we study for our midterm after this, we'll have to remember back how that other stuff works. So our last one, or not last one, but for dividing, if we have a polynomial on top and a monomial on the bottom, we're doing the same thing. We're essentially distributing this 2x to each of the terms, so they each get divided by 2x. If you want to, you can write it all out. It's okay if you don't in this case. What we're really thinking is what is 50x to the power of 4 over 2x, as if that were our fraction. So what's 50 divided by 2? 25. And then we have 4 x's on the top and 1 x on the bottom. How many x's will we have left? 3. There we go. Okay, and now we're done with that one. We can move on to this stuff. So what is 16 divided by 2? 8. What is x to the power of 3 over x? Okay, and what should I put here in the middle to attach those two terms? A plus. Essentially, because we had positive 8 as our answer, we'll use a plus sign to attach them together. And lastly, this one here, we have 2x squared divided by 2x. So what's 2 divided by 2? 1. And in this case, I almost would recommend just at least starting with that 1. If there was nothing, if all of the variables canceled out, it would at least remind us that we need to have something there. But in this case, we have x squared on the top and x on the bottom. What will survive? Just an x. So in this case, we didn't have to have the 1. It's optional. I won't be mad if you put it though. So sometimes it's just a good safeguard. Can I join these three things together? No. Because we have x cubed, x squared, and x to the power of 1. So they're different. Any questions there? Okay, I can guarantee you, and I don't always do this, on your test there will be questions. I think the only algebra tile questions are like this, where what I'm asking you to do is either multiplication or division statement. And so what do I mean when I say a statement? Yeah, we're looking for the question and the answer. And so looking at this, it's only giving us part of it, so we'll need to figure out part of it. But this means our question and answer. So we need to look at this and say, okay, how do we fill in the middle of this stuff here? And we're really looking at the shapes of the width and the height of certain things. So we're saying whatever goes here needs to be the width of this shape and the height of this one, which means it needs to be a rectangle. Should I color that rectangle in? Why not? Yeah, we have a negative times a positive, which we know is negative, which means that we're going to leave this not colored in. We're going to have a lot of those little rectangles. I'm so sorry. I won't make it this bad on the test. I realized this after I printed that this looks terrible. So we have 5 rectangles there, and then another 5 rectangles next to it. So sorry. I know I cheated. And then how do we fill in the end bit here? A bunch of little squares. I'm so sorry. Should the squares be filled in or not? They should be filled in. Yeah, so again, the reason why they're little squares is because it's the width of this and the height of this, which is tiny and tiny, so they're little squares. I promise you on the test it's not like this. Yeah. The reason why I chose this on the practice test is because when we make this multiplication statement, we're going to see that it checks out with math that we already know. Yeah.
I know probably we aren't quite there yet, but like, would it just stop working if like one of the sides had a bigger square?
Yeah, if we had a big square here, we can't really do that. Algebra tiles are good at illustrating some things, but they're definitely limited with their uses, because if we had like a big square and a big square, that would end up being x to the power of 4, which is a fourth dimensional shape which doesn't exist in our 3D world, so we can't do that. So this is, this is good for us with smaller polynomials, not great as the degree gets higher. So when I say a question and answer, what we are looking for, the question part of this multiplication statement is what you were given. We've got this, and we've got this. And so what is this as a polynomial? That's 5. Excellent. What is this as a polynomial? Negative 2x plus 3. And it equals whatever we were given in the middle here, which is, we've got 10 little not filled in rectangles, so negative 10x. And we have 15 little squares that are filled in, so plus 15. And so this is really illustrating for us what we've just done in the other questions, where we say, oh, we distribute it, and look what we get. So this way we see the picture that shows something we've already done before. Yeah. Our next one, same idea. This one is a division question because we're not given this top bit, so we're kind of given the big stuff, and we need to figure out what would go here. It's the same idea. We're saying, okay, if this big square came from whatever this is multiplied by whatever goes here, well, then this would have to be a rectangle. Another hint, we will never put a big square up here. I'll never do it. So don't, because that would mean that we would have like a cube here, which we don't. So I will never put a big square up there, so don't even worry about it. Should I fill this rectangle in? Yes, because we have a positive times a positive is a positive. We got another rectangle right here as well. What should go at the very end there? A little square. Should we color it in? Yep. And so, again, actually writing it as a division statement is a little bit of the tricky part. We want to remember this is the numerator, this is the denominator, and this is the answer. So we're going to start with 2x squared plus 1, because that's this stuff. Sorry, not 1, it's x. My bad. Dividing by whatever's over here. What's this? X. Equals what we have as our answer. So we came up with the answer, and we got 2x plus 1. And again, the reason why I chose this example here for our study guide is because that actually is stuff we know, is if we had done 2x squared divided by x, we get 2x. If we do x divided by x, it's not nothing, they don't fully cancel each other out, we get 1. Okay, our last bit here is one example on order of operations. So this is where we look at a question and it looks intimidating and we're like, oh, where should I start? And remember, order of operations means BEDMAS. But with polynomials, which letters of BEDMAS are tricking us? B and E. We will see a lot of brackets. We will see a lot of exponents. There's not really much we can do with them most of the time. Because if we look at these brackets, we have 2x minus 3. You can't actually join any of those together. So we can't do anything in the brackets. Is there anything we can do in the brackets here? No, they are not like terms. Same with exponents. We see this exponent here, but that's the degree of the term. There's not actually anything we can do with it. So we move on to division and multiplication. Technically, we have both multiplication here and division. What should we do first in this case, though? We want to do the multiplication here because what we want to do is if we have division, that's great. but we need to fully simplify the top and the bottom if possible. And here we have a lot of stuff we could simplify on the top. So what we are doing is we're taking this 5x and multiplying it to everything in its set of brackets. We can also take this 2 and multiply it to the stuff in its brackets. And so our first step is just dealing with that. So the 5x times 2x is 10x squared, and then minus 15x. So this came from here. And then we have plus 2 will get multiplied by everything in its set of brackets. We have plus 2x squared minus 2x. We still have the 2x on the bottom. And then basically we can ask ourselves again, is this as simple as it can get on the top? No. We can join some stuff together for sure. We can take together our 10x squared and our plus 2x. So that'll be 12x squared. We can also bring together our minus 15x and our minus 2x. So that'll be negative 17x. All of that is over 2x. Awesome. And then our last bit is now, is this as simple as it gets?
No. Well, yes.
At the top, sorry, the top of the fraction, is it as simple as it gets?
Yeah.
Yeah. So now we can move on to the division. Now we can actually say, okay, what is 12x squared divided by 2x? And we get 6x. And then we're done with that. And, oh, this one's interesting. What is negative 17x divided by 2x?
8.5.
Negative 8.5. We are absolutely allowed our calculators. Yeah, for the rest of the course, we're allowed calculators. So sometimes that might happen. It doesn't mean you got the question wrong. Maybe it just means the question has decimals, and decimals are allowed. There will also be questions that may include grid multiplication and geometry questions. Actually, grid multiplication, you might just want to remember for the bonus question. Just saying. Yeah. Ah, yes. These cancel each other out. Oh my gosh, so sorry. There we go. I got all excited about the decimal that I messed up with my x's. There will be geometry questions. My recommendation for you right now is you don't necessarily have to start our practice test from the very beginning. If you're feeling pretty confident with the earlier skills of the unit, I would jump to the end and start with some of our bigger stuff. If you're feeling less comfortable with this unit, I would say start with the beginning of the practice test, but not everyone has to start at the same spot. And yeah, I'll have the answer key up at the front here. The rest of the block is yours to practice.